Welcome to another joint solution video for the Mira Encrypted Traffic Orchestrator, also known as the ETO. In this video, we'll be shown how to maintain a high network availability when the Mira ETO is connected to the network as an inline appliance via the EdgeLens Focus Inline Security Packet Broker from Garland Technologies. In this setup, we will have the Garland device installed inline at the network edge. The purpose of this device is to manage the availability of multiple inline devices with the option to send out-of-band tap traffic to multiple devices. First thing first, the Garland box connectivity for optical interfaces P1 and P2 will be connected to the left-right side of our network. In other words, the internet in our internal network. If there is a failure, these two interfaces will be bridged together, bypassing the inline appliances. The Mira ETO network ports NetA and NetB will be attached to a default inline tap on the Garland device, and the connectivity for the ETO's inline security appliance will be done directly to the ETO's application ports App A and App B. The ETO, which is configured in an inline mode, receives 100% of the network traffic flow from the Garland device via P9 and NetB port on the ETO, allowing it to actively decrypt the network traffic when the SSL-TLS handshake occurs. ETO can then pass the plaintext data to its attached inline security appliance via NetA to P10 on the Garland device. If the flow of traffic through the ETO and its attached appliance is broken, as can be seen now, simulated via the ETO's app port down, the Garland device will automatically bypass the ETO, maintaining the network connectivity for the end nodes, avoiding any network downtime. The ETO and its attached appliance are no longer a single point of failure. To make things more interesting, we will keep the same setup we showed in the first scenario. And think of this case. What if we wanted to implement the defense in-depth principle or add in multiple layers of defense to our network alongside the resilient fail-to-wire setup? How can we achieve that? We can add another passive security device to give us this functionality. Let's take a look at this new connectivity diagram. You will note that we can add the Silks virtual machine from Stamos Networks working as an IDS by utilizing the mirror import functionality that the ETO offers alongside Garland's packet broker functionality. So let's go to our ETO. We will start by going to Segments, then Edit, then activate the mirror mode. And by doing that, we are sending a copy of the decrypted flows to a passive security tool, in this case through Garland's ports. And to make sure that the traffic flows in its decrypted format will be seen by the passive security device in case of a failure on the inline security device, we need the forward traffic, even if not seen by attached appliance option, to be activated. We will save and activate our segment. Then we will go to the Garland Web UI and click on Packet Broker, then choose Filter Templates to create a pass-all filter. We will save it, and after giving it a name and a description, then we will apply it to receive the decrypted traffic flows from ETO and send it through the Garland box to Silks using P39 and P40. And as we can see here in our Silks machine, traffic flows are being received on the if box page. The icing on the cake would be to create another customized filter to deny or block UDP flows. For example, if you don't want the security tools to analyze these flows. Finally, the main advantage of using the ETO mirror import via Garland's packet broker is that you can send traffic copies to multiple passive security tools, even using different filtering patterns if needed. Together, Garland Technology and Mira Security are capable of increasing performance and enhancing the effectiveness of your security and monitoring tools by removing any blind spots in the enterprise network. Thank you.